Okay, let's hope this works. I can't see what's going on here. Okay, right, take 209. I hope this is recording. I'm not absolutely convinced it is. Let's see. Well, maybe this will work finally. Okay, so here's the review, Trig Graphing Review 2020. And we're first of all going to graph y equals, I'm going to do it on paper just so I've got more room in case I want to explain stuff. Okay, so what we're looking at is plus or minus, that would give you the amplitude, the vertical shift, a times, there'll be a function and you're going to do sine, cos, tan, cosecant, secant, whatever, of b times x minus c plus d. The first thing you graph is this number at the end. That will give you your midline. Then you graph this and it tells you how far up or down. It's your vertical stretch gives you the amplitude of the function. Then you decide where it's going to start and you have to work out the step size. B will change your period. Period will be, it's either pi over b or 2 pi over b, depending on what type of function you're graphing, divided by b. B will compress it. And then you have to cut the period into 4 steps. So that always takes a little bit of work. So this one, let's just dive in and get straight on with graphing this. It's up to, I'm going to make each line be 2. So that's going to be our midline at y equals 2. Put numbers on, we need new numbers on the axes. Then it's going to go up and down. It's got a vertical stretch of 3. So it's going to go up and down 3 from there. 2 plus 3 will take you to 5. 2 minus 3, 1, 2, 3 will take you to minus 1. And these are your high line and your low line for your graph. And we're going to graph the pattern and we're graphing cosine. The pattern for cosine is high, middle, low, middle, high. So that's which of these lines to use, high, middle, or low. You've got to know these patterns. Then we look at the start. So where will we start? Well, that would be changed if it would definitely be inside parentheses if the start had been shifted. This is not a horizontal shift, that's a vertical shift. You can tell because there's no parentheses around it. So we have 0 shift here. It's just cosine of plain old x. So we're just going to start on the y-axis at x equals 0. The period has not been compressed. If there was a value of b multiplying the x, that would change the period. But we've just got the period of a normal cosine, which is 2 pi. The equation we'd use there would be 2 pi divided by b, and we've just cosine of 1x. So ours is just going to be 2 pi. And then whatever that period is, you always break it into 4 steps. So we'll get 2 pi multiplied by 1/4 or divided by 4 will give us a step size of pi by 2. So when we're graphing, we're going to start on the x-axis on the high line. So go to the high line on the y-axis and then circle that start point. Make your points really obvious. We grade you on those. We've got to see where you put them. Then takes 4 steps forwards. Each one is pi by 2. So that's 1 pi by 2, 2 pi by 2, 3 pi by 2, 4 pi by 2, and put labels. You can just say that's 2 pi by 2, or if you want to, you can reduce that number to pi. This would be 3 pi by 2, this would be 4 pi by 2, which if you want to, you can reduce to 2 pi. Then take 4 steps backwards. 1, 2, 3, 4. And these need the labels. So that'd be minus pi by 2, this would be minus pi, this would be minus 2 pi. I'm just labeling every second one there. So going forwards through our pattern from high, going forwards, I take a step, which will be take me to my next tick mark, high, middle, on the middle, take another step, go to the low, which was down here, then take a step, go back to the middle, take a step, go to the high. Now that's one cycle going forwards. Now come down after it. After that high, it's going to go back to the middle. And then take 4 steps going backwards. So we're on the high. You should always start and finish on the same point. And then you can go backwards through your pattern. High, middle, low, middle, high. High, take a step, that's to here. Middle, take a step, which takes us to there. And we're on the low line, which was down here. It's getting lost in amongst the labels, that one. And then back to the middle, take a step to the middle, and then we take a step to the high. I've run out of room there a bit. Don't forget, after this high, you're always going down. You're not going up above it at a high. So that was number 1. Let's do number 2. And question number 2 is y equals 3 tan of 2x minus 1. Now notice there's no parentheses here. This is a vertical shift, not a horizontal shift. That's our D, not our C. Okay, so let's graph this. We're going to be going down 1. I'll make it small again. Down 1. Then we've got a vertical stretch of 3. So go 3 up. 1, 2, 3, which will take me to y is 2. And 3 down. 1, 2, 3. That's taken me to y is -4. That one was at -1. Then, so I've done this and I've done that. The pattern for a tangent. That starts on the midline and it's normally increasing. You have to find your own way of remembering these. I have to talk to myself a bit to do it. Middle, high, asymptote, low, middle. That's my pattern for a tangent. So I'm going to start on the midline, but where? Okay, that was a vertical shift. It wasn't a horizontal shift. Again, I've got no horizontal shift, so I'm going to be starting on the y-axis where x equals 0. So where x equals 0 on the midline, that's here, that's my start point, circle it. Then I've got to take a step and go to the high. Take a step. And look what I've done here. I can get the shape of the graph without even, when I'm starting on that y-axis, I could just take 4 steps forward and 4 steps backwards and not label them. Now you'd lose points for that. We need to know how big those steps are, but you can actually come up with the shape of the graph without that. Take 1 step to the high, take 1 step to an asymptote. You always step to the asymptote and step moving away from it. Some people sort of shove the asymptote in just between points. That's wrong. Asymptote, step to a low, and then step back to the mid. So that's 1 cycle going forwards, but look what's totally missing from that graph. There's no indication of how far I'm going along this x-axis. So we have to work that out. You don't just work out the start, you need the period. Now the period for a tangent is usually pi. So if it gets changed to be pi, that's compressed by b. And our value of b is 2. That's compressing it from what the parent function would normally be. So it's pi by 2. And this has to be broken into 4 steps. 4 steps or quads. So to divide it by 4, it's going to be easiest with this one to, instead of dividing by 4, multiply by 1/4. That's the same thing. Multiply across the top, pi, across the bottom, 8. Each step is pi by 8. Now I can just go in and label them. That's 1 pi by 8. Just keep all the denominators the same. Count 1 of them, 2 of them, 3 of them, 4 of them. 1 pi by 8, 2 pi by 8, 3 pi by 8, 4 pi by 8. Oops. Where you've got an asymptote, label that with its equation. And if you wanted to, you could reduce that. There's nothing wrong with saying its x is 2 pi by 8, but it's better math to reduce it. So that's 4 steps going forwards. We've gone forwards. Now let's go backwards. And you should always end your pattern with the same letter you started with. So try and make your steps about the same size. 1, 2, 3, 4. This would be at minus pi by 8. This would be at minus pi by 4 or 2 pi by 8, minus 3 pi by 8, minus 4 pi by 8, which is the same as minus pi over 2. On this side I've reduced them, that side I didn't. Just reminding you can leave them all over 8 if you want to, it makes it easier. So from the midline, take one step backwards and I go to the low. There's one step, go to the low. Take one step backwards from there and draw an asymptote. So that's x equals minus pi by 4. Take one step back, go to the high. So I was there to the high. And then take another step back and go to the mid. From the mid, go through the high, up the asymptote. From the mid, go down through the low, down the asymptote. Okay, so that was number 2. Let's have a look at number 3. Question 3 is, let's graph y equals, didn't show that, minus sine x minus pi over 2 minus 1. Okay, so I'm graphing y equals minus sine. That's going to reverse that's going to flip all the highs to lows and lows to highs. X minus pi over 2 minus 1. So here we go again. Just graph that minus 1, shifted down 1, so that's going to be at minus 1. The amplitude here is just 1, so we'll be going up to the x-axis for the highs and down 1 to -2 for the lows. Oh, this is going to be an ugly graph the way I've graphed it. Laid up my scale badly. The pattern for a sine is normally middle, high, middle, low, middle, but because it's negative, that high will become a low, that low will become a high. Okay, I'll start. This has shifted us. When it's minus, you're actually shifting right by pi by 2. So we're going to start at x is positive pi by 2. On that midline at x is positive pi by 2. Don't graph that yet because we have to work out what the step size is and we want the start and the step to have the same denominator or the graphing is horrible. It's hard to do. Okay, so the period, our value of b there is just 1. We've got 1 times that there. So for period, for sine and cosine, you use 2 pi divided by b. You'd use 1 pi divided by b there if it was a tangent or a cotangent. All the others use 2 pi divided by b. So it's just 2 pi divided by 1, which is 2 pi. And your step, you get that 2 pi divided, always, always, always divided in 4 steps. So that simplifies to pi over 2. Oh, that's going to be simple to graph. The start and the step are actually identical. You want them to have the same denominators, even easier when they're identical. So that's going to be my start at pi over 2. And then I'm going to take 4 steps forward. 1, 2, 3, 4. And I'm going to take 4 steps backwards. Don't forget the y-axis there is going to be a step. It isn't always, but in this case it will take us to 0. That's 1, 2, 3, 4. Let's label these up. This was 1 pi by 2. Now I'm going to have 2 pi by 2, 3 pi by 2, 4 pi by 2, 5 pi by 2. This was our starting one. 0, minus 1 pi by 2, minus 2 pi by 2. I could have just written minus pi there. I could have just written plus pi there. I could have just written 2 pi there. But I'm leaving them all with the same denominator. Minus 3 pi by 2. And that was 4 steps backwards. So we're ready to graph then. The pattern says start on the midline, which is this one at x is minus, y is minus 1. Start at pi by 2 on the middle. Then the pattern says go to the low. So take a step, go low. Take a step, go middle. Take a step, go high. That's here on the axis. Take a step, go middle. So does that look like a sine wave that's been reflected? Yes, it does. Now start from that middle. Oh, we should have circled it. Start from your starting point, circle it. and go backwards. So from the middle, I'm going to go to the high, actually on the origin that point, then to the middle, then to the low, then to the middle. Okay, and you can put little arrows on the end of that, go on forever. So that looks like a sine wave. Sine and cosine waves always look consistently like this. You know, you're just starting some different place with a smooth waves going on, looking very repetitive the whole way along. Okay, so that was number 3. Let's do number 4. And question number 4 is a cotangent. Y equals cotangent of x minus 3 pi over 2 plus 2. Okay, so let's put on the high line, the midline, high and low. I go up 2. Oh, I've used one line. I'm being inconsistent here. That's going through y is 2. My amplitude here is 1. So I'm going to go up 1 from there, which my high line will be at y is 3. That's the midline, and down 1 from there. Low. This distance between these should always be the same. Should work on every single graph, going up the same as you're going down. Okay. And then we need to know the 3 things we always need to, 4 things. Pattern first, cotangent. They always start with an asymptote. Asymptote, then they're decreasing. Asymptote, high, middle, low, asymptote. You need to memorize these patterns, find a way to remember them. Our start this time is going to be, this is going to take us right by 3 pi by 2. So we're going to start at x is positive 3 pi by 2. That's the phase shift, how far you've shifted left or right. The period, it hasn't been compressed, b is 1. So for a cotangent and tangent, the equation you use is pi divided by b, because the period on the parent function is only pi, not 2 pi. So our period is simply going to be pi, and our step length is that going to be divided into 4. So it's going to be pi divided by 4. Okay, now when I'm graphing this, these 2 need to have the same denominator. This is going to be easiest graphed if I change this one's denominator to 4 by multiplying top and bottom by 2. So it's going to be at 6 pi divided by 4. Okay, so we're going to have to count across. I'm counting pi by 4s. 1 pi by 4, 2 pi by 4, 3 pi by 4, 5. That's 1 pi by 4, 2 pi by 4, 3 pi by 4, 5 pi by 4. I missed 4, didn't I? 4 pi by 4, 5 pi by 4, 6 pi by 4. And that's just the start. I'm going to need another 4 after that point. 7 pi by 4, 8 pi by 4, 9 pi by 4, 10 pi by 4. 7 of them, 8 of them, 9 of them, 10 of them. Okay, your numerators are just going 1, 2, 3, 4, 5, 6, whatever your denominator and that stuff is. Okay, and then okay, we can just we might not. I don't think we're going to need to go backwards, because if we start at 6 pi by 4 with an asymptote, (6 pi by 4), label it. That would actually reduce to, you can write 6 pi by 4, there's nothing wrong with it, but another correct answer would 3 pi by 2. This is kind of a bit better math, but we're not that fussy. Okay, so circle the start. Well, you can either circle it, I don't mind, you can either circle it here on the x-axis or circle it on the midline. One of those two would be fine. And we've got to go through our pattern now. From the asymptote, we're going to go to that, take 1 step, go to the high line, take 1 step, go to the midline, take 1 step, go to the low line, take 1 more step, go to the asymptote. Label that. We're going to either label it 10 pi by 4, or if you want to be super good, you can reduce that to y is 5 pi by 2. I really don't mind. So that's one cycle. Go up through the high, curve down through the low on the asymptote. Now let's go backwards. From this asymptote, that's here, we're going to take a step backwards, and each step is just 1 pi by 4. So take one of our steps, go to the low, take another step, go to the mid, take another step, go to the high, take another step, and you've got an asymptote. So that asymptote is at 2 pi by 4, which could be labeled as x is pi by 2. Either of those labels is fine. Then get from the middle, curve down through the low, and curve up through the high. Okay, so that was question number 4. How are we doing for time? Let's do 2 more graphs. We'll do the front and we'll stop this video and then we'll start a new one in a second. So we've got a graph now, a cosecant and a secant. So if we're graphing a cosecant to cosecant, oh, look, you've got to factor out that 3. If you had 3x plus pi minus 1, then that wouldn't be the start. If there's a value of b and a value of c, you've got to factor it out of both of them and bring it into front there like that. Okay, so that's what we're going to be graphing. That's going to turn into 1 there. When you're graphing a cosecant, remember that a cosecant is the reciprocal of sine. So what we're actually going to graph, just to get to know what we're doing, we're going to graph 2 sine of 3 times x plus pi over 3 minus 1. We've replaced the word cosecant with the word sine, and sine has a pattern of middle, high, middle, low, middle. And what's going to happen is all these mids will turn into asymptotes. The highs will stay the same. The lows will stay the same. But every time there's a midpoint, we're going to draw an asymptote instead. That's what happens when you're graphing a reciprocal. Okay, so that's going to be the pattern we graph for the cosecant. Okay, so first thing to do is this down 1 with an amplitude of 2. So down 1 at minus 1, that's going to be all my midpoints. And look, there's going to be none of them in the actual, that'll be the cosecant, but I am going to graph them when I put in my construction line for the sine. Then the amplitude is 2. So I'm going to go up 2 from that, which takes me to 1. And that's going to be all my high points on the high line. And down 2 from the midline, take me to minus 3. That gives me all my lows. My start, I've moved left pi by 3. The period is going to be compressed by 3. So the period is going to be 2 pi divided by b, and my b is 3. So it's going to be 2 pi over 3. And the step, get that period and divide it by 4. Well, that's going to be easiest to multiply by a 4th. So that gives me 2 pi over 12, which reduces to pi over 6. Now the step and the start need the same denominator. So I'm going to rename negative pi 3, multiply top and bottom by 2. So I have negative 2 pi over 6. That's going to now make it easy for me to put my scale. On my scale, I'm going to count my scale in sixths, and I'm going to start 2 marks backwards. Ooh, look, I put my y-axis in the wrong place. Yeah. Most of my graph's going to go, I should have planned that from the beginning. Negative two steps. 1, 2. That's negative 2 pi over 6. Take 4 steps forward. 1, 2, 3, 4. So that's at negative 2 pi by 6, negative pi by 6, 0, pi by 6, 2 pi by 6. And keep track of the fact that's the starting one, and 4 steps backwards. 1, 2, 3, 4. I've made this a bit crushed in, haven't I? Negative 2 of them, negative 3, negative 4 of them, negative 5, negative 6 of them. Oh, that's negative pi there. Okay. Right, let's graph in. You can choose. I'm going to graph in the sine. I'm going to graph in the sine very lightly and then show you how you change it. Pretend we didn't know that, okay? Graph in the sine. So at our start, I'm going to be on the midline. Negative 2 pi by 6, I'm on the midline. Take a step, go to the high line. Take a step, which is actually going to take me onto the y-axis. Go back to the midline. Take a step, go to the low line. Take a step, go to the midline. Now, this is not my actual graph. This is the graph of the sine. To turn it into the cosecant, wherever this graph is crossing its midline, I put an asymptote and circle where it crosses its midline or where it crosses the x-axis, and say that is at x is negative 2 pi by 6, which you could just simply label as negative pi by 3. Okay. This high is going to be where the smile comes in. Where it crosses its midline, we get the asymptote. So this graph is another asymptote at x equals 0. That would be where the frowny part comes in. Another step. You have to get the asymptotes in place before you can do anything. That's at x is positive pi by 3. Now the actual graph, I'm going to do it in red. This is the graph of the cosecant. You smile on the highs and you frown on the lows, and it will go down those asymptotes forever. That's one cycle going forwards. To do a cycle coming back, I just work backwards through that pattern from the midline, low, middle, high, middle, midline, step to low, step to middle, step to high, step to middle. Put asymptotes through all the midpoints. So this is an asymptote at x is negative 4 pi by 6, which is negative 2 pi by 3. Then there's another asymptote where it crosses its midline here. So that's x is negative pi. And then just put a frown on your low parts. Goes through that point. Those points are exactly at the same height, and a smile on the high. So the red part there is the graph of the cosecant, right? And one more here, we've got to do a secant. So graph number 6, we're graphing y equals negative secant of 2x plus pi plus 1. Okay, first of all, I'm going to factor out that 2. So we've got y equals negative secant 2 times x plus pi over 2 plus 1. And to graph it, I'm not going to graph secant, I'm going to graph its reciprocal. I'm going to graph the cosine, which is going to go high, middle, low, middle, high. But hold on, it was negative cosine. This would be a low, this would be a high, this would be a low. And then when I actually graph it, I'm going to put asymptotes through those midpoints. Right, let's graph this then. So first thing you always graph, vertical shift up 1. And I'm going to be going left. I'm just planning where to graph it this time. So we're going up 1. My midline is going to be at y is 1. That's the midline. The amplitude is just 1, so I'm just going to go up 1 to get to the high line. looking for numbers there. Down one, okay, that's actually this. It's not an asymptote, it's just a construction line. It's going to be on the x-axis. And my start, the start is going to be at x equals negative pi by 2. Ooh, I haven't left myself enough paper here. I'll do the period over here. Period. For a secant or cosecant, sine, cosine, we get 2 pi and we compress it by b. So that's going to give me just pi. Then the step is going to be 1/4 of that. So pi divided by 4, 1/4 of pi. And this need the same denominator, step and start. So I'll rename that as, to turn that into 4, multiply top and bottom by 2. Multiply by 2. Negative 2 pi by 4. What's the smallest thing I've got to graph? Pi by 4s. So, and I'm going backwards 2 of them. Negative 1 pi by 4. Negative 2 pi by 4. That's going to be my start. And let's just graph the cosine very lightly. I'm going to go low, middle, high, middle, low. Low line. Take a step, which is pi by 4, midline, take a step, high, need some more steps, pi by 4, 2 pi by 4, low, middle, high, middle, low. Now that's the cosine, negative cosine, and I'm going to turn that into a secant in a minute. Circle that first point. Go backwards 4, low to middle, middle to high, middle, high to middle, middle to low. Okay, so 4 steps. Try and make them the same size. 1, 2, 3, 4. Label them. That was negative 1 pi by 4, 2 pi by 4, 3 pi by 4, 4 pi by 4, 5 pi by 4, 6 pi by 4. From the low, I go middle, high, middle, low. This is just a construction line because I really have to graph secant. How I graph it to secant is through every midpoint I put an asymptote. So I've got 1 here, 1 here, 1 here, 1 here. Those need to be labeled. This is at x is negative 5 pi by 4. This is at x is negative 3 pi by 4. This is at x is negative pi by 4. And this is x equals pi by 4. And then put your smiles and frowns on. There's a high point, smile on the high. There's a low point. We've got room for half of a low there. It does carry on. Then there's a low. That was our start. Through this high, put a smile. And through this low, we need at least half of that smile. Then it would carry on. And just look at the pattern. If you wanted to know where all these asymptotes are, just look at the pattern. Minus pi by 4, minus 3 pi by 4, minus 5 pi by 4. Can you see they're going up in odd numbers? There'd be one at negative 7 pi by 4, one at negative 9 pi by 4. Going forwards, this was at 1 pi by 4. There'd be one at x is 2 pi by 4. No, there wouldn't be. That'd be 3 pi by 4. Then 5 pi by 4, 7 pi by 4, 9 pi by 4. Okay, it's useful to notice those patterns in the asymptotes, and you'll see why when you take the test tomorrow. Okay, right, let's just finish off the front of this, and then I'll start a new video for the back. So here I've got these 2 equations. Number 7, y equals 3 sine of, 2. That's already factored out. That's good. That means we can just read it directly. Okay, so we're being asked for the amplitude, that's this. And it's always positive. Even if there'd been a minus in front of there, you say your amplitude equals, it's always a positive number, 3. The period, well, the period's going to be compressed by 2. The period, there's 2 equations you use. You either use 2 pi by b or you use 1 pi by b. You use 2 pi by b for cosine, sine, cosecant, secant. Use this one if you've got a tangent or a cotangent, okay? Now, we're using sine, so I don't want this one. I want to use this starting equation. My value of b is 2. So I've got 2 pi divided by 2, which is just pi. The phase shift, okay, phase shift is your horizontal shift. It's where we actually start the graph. This is your phase shift. C gives you your start or your phase shift. And this, if you're subtracting, remember they're going the wrong way, this would be right by pi by 6. So your phase shift is going to be pi by 6 to the right. You could just write x is positive pi by 6, something like that, okay? And then your vertical shift, that's coming from this at the end, is going down 4, okay? The midline would be at y is negative 4. That was number 7. Let's have a look at number 8. Y equals negative 4 cosine of 5x plus 3 pi minus 3. Before you can do anything, there is a value of b and a value of c. You must factor out that 5. So I'm going to divide by 5, and factor that 5 out. My b equals 5. My c equals 3 pi by 5. The d is negative 3, and your amplitude is positive 4. That minus would just change the pattern. Instead of being high, middle, low, middle, high, it'd be low, middle, high, middle, low. Okay, so again, my amplitude equals positive 4. Very definitely not negative 4. Okay, positive 4. Amplitude's always positive. The period would be 2 pi divided by b. I used that for yes, it was cosine. I was just thinking it might have been a cot question there. Look out. Oh, that would have been bad. It's going to be 2 pi divided by 5. Then the phase shift is your horizontal shift. And it's being moved to the left by 3 pi by 5. So the start would be at x is negative 3 pi by 5. And the last thing we have to do is a vertical shift. Your vertical shift is going to go down 3. So your midline is going to be y is negative 3. We're writing a description. I'd probably say down 3 there. I'd probably say left 3 pi by 5 for that. Okay. If it's just a numerical answer, you put negative 3 pi by 5 and negative 3 for that. Okay, let's hope this video has worked.